Okay, keep in mind, two major types of problems, or two main types of problems. One is where you're given the graph and you have to come up with the equation, and the other is where you're given the equation and you have to determine the graph. Right now, we're only dealing with straight lines, so this isn't too bad. It's going to get much more challenging down the road when we do what are called conic sections, but for right now, we're dealing with straight lines. Now we throw a little wrinkle into the mix, and the wrinkle into the mix is, suppose we're told to graph something like, let's say this, and that's not an equation, it's an inequality. So let me just show you how we're going to graph it. And just like we did with inequalities themselves, we're going to, in a sense, if you will, pretend that's an equal sign just for a minute and make the graph. So try to keep in mind that this was we have to be careful about something here, but watch. Let's just pretend that's an equal sign, and let's solve for y first. I prefer to write the equations of lines in y equals mx plus b. You don't have to write it in that form, absolutely not, but I think it's a good, useful form to write in because it helps give you a quick feeling for what the line looks like, because you can see the slope and the y-intercept just by inspection. So let's solve this for y. I'll tell you what, look, if it were me, I'll tell you what you would see next. You would see this. You would see 2y equals 3x minus 8. Now I'm leaving out a little bit of work. Now what did I actually do? Well, I thought to myself, let's get the negative 2y over here by adding it, and let's get the 8 over here by subtracting it, and then we'll switch sides. Thing of it is, now I got to be really, really careful because we're dealing with inequality. Sorry, I'm looking for something to erase this with here. Okay. You know what? We could keep track of this, but maybe a little bit better. Let's go back and let's put that inequality sign in there. I mean, second thoughts about this. Here, we'll make that a less than sign. Let's add 2y to both sides. And notice, when you add or subtract the same thing to both sides of an inequality, you don't have to worry about flipping the signs. You don't flip the signs, so you don't have to worry about it. Let's subtract 8 from both sides. 3x minus 8 is less than 2y. Let's switch sides. Here I've got to be careful. Look, if this is less than this, then this is less than this. So, or this is greater than this. So we can write it like this. See how this 2y is greater than this? So 2y is greater than this. And let's divide by 2. I'm dividing by a positive number, so I don't have to switch the inequality. So 3/2 x minus 4. Now, if you look at this temporarily as an equal sign, y equals mx plus b, it's a straight line, the y-intercept is -4, and the slope is 3/2. And what that means is we can make a good graph really quickly. Here, I'm going to erase this. This really was the original problem, but it's equivalent to this, so they're the same thing. So by me erasing this, I'm not really getting rid of anything because, after all, this is the inequality that we started with, just in a different form. Let's make a graph as if that was an equal sign. Just pretend it was an equal sign. Now, again, when someone says make a graph, that's a little bit vague. How detailed? What features should you show? One thing you should always try to show are the x and y intercepts. Now, when it comes to a straight line, if you show the x and y intercepts, that's 2 points. If you have 2 points, that completely determines a line. That's pretty much the whole thing. There's another way that just works with straight lines. This won't work with other things, but with straight lines it will. When I look at this, the y-intercept is -4. So 1, 2, 3, 4. There's the y-intercept. The slope is 3/2. Remember, slope is rise over run. So every time you go over 2, you go up 3. So I could go over 2, 1, 2, 1, 2, 3, over 2, up 2, over 2, 1, 2, over 2, up 3. And you can get a pretty good graph that way. Now, in this particular style of graphing, I didn't happen to get the x-intercept. I did get the y-intercept. That's the point 0, -4 right there. Again, I think it's a good practice, it's a good habit to always try to indicate what the x and y intercepts are. How do you find the x-intercept? You set y equal to 0. So let me just do a little, yeah, work off to the side. I can do it up here. 0 equals, I'm just make it equals for a second. 3 halves x minus 4. Let's add 4 to both sides. And divide both sides by 3 halves, so we get 8 thirds, just 2 and 2/3. So 1, 2, 3. So there's the graph. Well, that's actually not the graph of this inequality. This right here is the graph of y equals 3x minus 4. Here's a good thing, or a nice thing. To graph this inequality, you pretty much do what you think you would do. What we're looking for are all y values, not that are equal to this quantity, but that are greater than that quantity. So let's say you're on the number line here. We're looking for all the values of y not equal to this value, but greater than this value. So any of those points above this point will have a y coordinate which is greater than 3 halves times the x coordinate minus 4. Whew, that was a pretty wordy way of saying the following. Everything I'm shading here, and there's no one right way to shade this, but the region which I've just shaded is the solution set for this inequality. If you take any point in this shaded region, any point, the point would have an x coordinate and a y coordinate. If you take the x coordinate and substitute it for x here, and the y coordinate substitute for y here, you'll get a true statement. Now, maybe if you haven't done so, and we'll be going and using some graphing software later on in the course, but right now if you wanted to, for example, if you just Google graphing, you know, the autofill will probably beat you to it, but if you Google graphing calculator, there are many out there, and most of the good ones I've seen are free, so you know, no need to pay any money. One of my current favorites, and it's not the only one, and it didn't used to be my favorite, but for the last couple of years, it's been my favorite, is one that's Desmos. And you just literally type in what you want to graph. So if you type in y and just the regular equal sign on the keypad and 3 halves x minus 4, presto, it makes a graph for you. And you can substitute the greater than or less than. And if you do, for example, if you substitute this, you'll see this is shaded above it. Now, there's a slight detail that you may not be able to detect on Desmos or other graphing software, and that's the following. This is y is greater than 3 halves x minus 4. What I actually have graphed here is y is greater than or equal to 3 halves x minus 4. The convention is, if you don't want to include the equal sign, that we make this a dashed line. That can be a little bit difficult to detect on graphing software. So if it's greater than or less than, not equal, no equal sign, we use a dashed line. If it's greater than or equal to, we use a solid line. Let me just leave this up here. Let me erase this fairly, I don't want to say terrible looking graph, because really it has all the features on it. It's not particularly beautifully drawn. But let's suppose we want to do less than. So again, what I would do is I would graph the straight line. Y-intercept is 4, negative 4, 1, 2, 3, 4. The slope is 3 halves. I mean, it's 1.5. So every time you go over 1, you go up 1.5. Or every time you go over 2, you go up 3. So we get something that looks like this. Now that it's less than, hey, let's see, less than or equal to. I would shade this region here beneath the line. Now, some people look at it as to the right of the line, and I mean, that's actually just as true to say. But I'm looking at this as everything underneath the straight line, y equals 3 halves x minus 4. If I took away this equal sign right here, then what I'd have here is dashed lines, or a dashed line. Okay, so this kind of problem is called a linear inequality in two variables. That's sort of a lot of words for something which isn't that difficult to do so far. Okay, and there's one other type of problem. Nah, I want to wait on that problem. I think I want to wait on that. Let's wait on that. That's good enough for right now. Now, as far as the test goes, I'm going to post the tests on Friday, like I said in the announcements, and each one of you will have your own version of the test of an exam. So you'll have an exam associated with your name. And I can't remember the exact hours, but I posted that. Maybe I said I would get it posted by 8 a.m. and the exam is due by 4 p.m. I really didn't have in mind that you would work 8 hours on the exam. That's not really the point. I mean, it's an exam that you should be able to do in an hour or so. Nonetheless, I guess if you want, hey, you have the whole day. You sort of have, so it's strictly speaking a time test, but really that's a lot of time. And I don't even know if I should mention this, but I would really like you to do your own work, if for no other reason, because I'd like to find out what you know and what you don't know. And this is really the first and only convenient way for me to find out. You can return your exam, like I said in the announcement. I'll say it now, and I'll say it on the exam itself. You could give me a Word document, a PDF. You could take a picture of your work on paper and just send me the picture. You could scan it. You could send it back to Canvas, or you can email it to me. So any of those methods are okay with me. Okay, so again, if you have questions on Chapter 3, please email me the questions, and I'll address them tomorrow, Thursday, before the exam. Or hey, Chapter 2. You have questions on Chapter 2? Let me know.